However, there's a few that have changed just because there's going to be more people. Um, so one of the things that happens when we have, just to start out with, one of the things that happens when we have more people in person is that we kind of just hang out and don't really do our warm-ups as often and things like that. So one of the changes that's going to come about as a result of that is part of your notebook checks, which they always have been, and I've kind of written down who's done it, but we are going to have discussions as warm-ups, not necessarily like us talking to one another, but kind of those things that we had before spring break, where it's like, well, what do you think is happening here? Or if we have some problems or something that we need to do, that's something that we go through and that we make sure that we've got set up. So um, after I do this, I'm going to make sure, for those of you who are in person, I'm going to make sure that everybody has their name on their stickies. The reason the stickies are there is just to make sure that we have, like, we know who sits in each seat and that sort of thing, and to make sure that everybody's, distant and all of that. But when we talk about this, warm-ups, responding to questioning, I know this is fourth period, okay? We struggle with this sometimes in class. Most of us do a really good job with it. Um, you've got to make sure that if we have in-class questions, or we have in-class activities, or things that I say, hey, in the chat, do blah, 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 okay? It's something that's going to be important for us to make sure that we're paying attention to that. For the in-person people, the masks, that is just a non-negotiable, okay? I know it's hot in here. It's just, it is what it is. We're going to try to figure it out. Some days, some weeks, we're going to go outside, and one, probably just blow stuff up for the heck of it, or launch things based on the physics portion of what we're doing, but also even just to take some of the sidewalk chalk out and do problems on the sidewalk, or something other than sit in a room, so that will be something that we try to plan for, and try to make sure. And we'll probably just go out here, but hopefully before it gets like ridiculously hot, we'll do that. But the last thing, bathroom breaks. Most of the time I can kind of stand kind of here and monitor the class and have you guys go to the bathroom, but just let's try to limit it as much as possible, even if it's coming by and saying, Mr. Kuhn, listen, I got to pee real quick, I'll be right back. Okay, and I know a couple of people did that. I don't know what y'all did in the bathroom, but said, hey, I need to go to the bathroom. They Haiti pooped. But the the point is that we need to make sure, because there's only a certain number of escorts. Depending on the escort, they may not come. Mr. Flowers is really good, but some of them aren't as good. So we just need to make sure that we limit that. Okay. And remaining in your assigned area, just making sure that everything's set up. I sanitize. I've probably sprayed every one of these desks off twice today. Okay. That's one, because Quez jumps around in here third period, but also second period was kind of like this, where most of the tables were taken up. So I spray the chairs, I spray the tables and all that. So we try to just make sure that that's set up. Now, number one, for the expectations for all students is pretty important, because this type of thing, let's do the remote stuff real quick. So same thing with remote, all warm-ups, in-class activities and stuff like that. If I consistently have to kick you out because you're not doing what you're supposed to be doing, then we're going to have a talk with your parents. We're going to have a talk with whoever we need to talk to get you where you need to go do what you're supposed to do. The other thing, and this goes for you guys as well, is we have to communicate. Okay, I don't want us to get to May 8th. You say, hey, I've been having problems. I don't know the difference between I'm not going to do my work and, hey, I've been having problems with the work, unless you communicate with me. Okay, so it's got to be something that we make sure. Now, this next one right here is a big one. Okay, especially for those of us that struggle with focus. I'm like that, and y'all might, for those of you who have dealt with me in class more often, or things like that, somebody will do something and I'll just stop what I'm doing and just be like, oh, they're doing something. Technology does the same thing for you guys. All right. So believe it or not, as of right now, um, as of right now, we grades are due and done on May 11th. Okay. That's 4 weeks. That's like no time. Okay. That's less than 4 weeks if we're looking at Wednesdays being half days. Okay. Now, are they going to change that? I don't know. Now they're talking about, well, now that you're going to school 4 days a week, we might change this again. I don't know. But the point is that we have to make sure that we are prepared for them saying, hey, this is it for grades. Because as of right now, all the grades are supposed to be cut off on May 11th. Okay. So we don't want to waste a bunch of time. Instagram and all that crap can happen in, at other points in time. Talking to him or her, trust me, if you make them wait a little bit, they'll want you more. And if they don't, then they're just too impatient for you anyway. Okay, so just as a matter of respect, I try to make sure my phone, and now if it goes off, it may, even then I'll probably hang up unless it's my mom or my wife. But just make sure that while we're doing, like I'm speaking directly to you guys, I don't look over and I see, I know all the tricks. I got it behind my book bag, I'm gonna do this. I got it under the table, I'm gonna do this. First of all, I can see under the tables. Okay, so just as a matter of respect, I'm not gonna do that. Just make sure that you guys don't, because it's just gonna, when you look up and say, hey, what are we doing? Da da da. Really, bro? Okay. Just make sure that that's something that we do. Okay. So, and I don't really care when we're during our independent time. Now, if you're not doing work, then we'll have something to say, but just make sure that that's something that we've got going on. Now, getting all activities done within the allotted time sounds pretty common sense, right? Do things when they're due. However, I just told you the real reason behind that. Okay. I don't know. Nobody knows. As of right now, the absolute cutoff, they're telling us grades are due the 12th. Like, we got to finalize it. Everybody in here is still in a possibility of being able to pass. Doesn't matter if you haven't done a darn thing yet. Okay. So let's get stuff done, and let's get stuff done with some sort of urgency. Okay. Same thing with being submitted on time, the cutoffs and things like that. And then 5 and 6 are kind of the same to me. Okay, obviously, somebody, if you guys are in person, you're not going to go over to my bamboo plant and slap it. Yeah, I've had students that if it's anywhere near them, they're picking the leaves off. Like, dude, just show respect to the things in the classroom, but also show respect to one another and to me. And that goes along with being on time. Okay. Every once in a while, if you've got to do something, I understand that. But if you're habitually late, like I can tell you which kids are going to be late. I can go down second period, third period, and fourth period and say blah, 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 and blah are going to be at least 10 minutes late. Stop it. Okay. And not only that, but you're going to be responsible for the stuff that you miss. And you're going to have to go in and watch the recordings instead of just getting it in real time and being able to ask questions. Okay. So all of that stuff is pretty simple. When we come in tomorrow, you will have a 5-question little quiz on this stuff. I don't care if you pull up what I just had. I'll send you the link to it. By you putting the words into the blanks where it says fill in the blanks, you know what my priorities are. Okay? So I'm telling you to cheat on the quiz tomorrow. It's a grand total of 10 informal points. Ain't gonna help you or hurt you. Okay, but it is something that is driving home what I just talked to you about. Okay, bring your butt on time, do your notes, like just simple stuff. Okay, so we're gonna do that tomorrow when we first come in. Today, we're gonna go through and we're gonna talk a little bit about net force. Okay, and so when we do this, then we're gonna have some demonstrations and some things that we'll potentially be able to do. I've got some kits and things like that. I really want to get to waves, because then we're going to play with slinkies and probably play with slinkies in the hallway and disturb others. So that's kind of how we That's how we're going to operate. But we're going to go through and talk a little bit about that. And then this discussion down at the bottom is kind of like one of your warm-ups, okay? It's actually going to be something that we look at. It's a very quick video. It's a very simple thing that you're going to do. And then basically your first grade of post-spring break is this net force practice activity, which I'm going to show you how to do. You're going to have to draw on it, but it's pretty easy overall, okay? So let's look at these slides. These slides are terrible in terms of like them being interesting looking, but they're decent. They're decent with the concept, okay? So Jermaine, you good? Oh Lord. You good? This is Coach Walker, y'all. He'll frequently visit unannounced. Logan? My friend too. Logan about to be knocked out of here if he's not careful. It's hot in here too. You put your head down if you want. Be knocked. All right, so when we talk about net force, okay? We talked about forces being a push and a pull, okay? And so net force, think about anybody have a job, legal or illegal, don't matter, okay? Well, it kind of matters, but in the grand scheme, this analogy, it doesn't matter. So you have, someone's angry. You have money that you put in and you have money that you get out of something. Okay, a lot of my friends do stock. I'm too busy to worry about like being able to research it and figure out what's a good stock to buy. They're like, buy Tesla. You look at Tesla, it's like $600 a share. I ain't doing that. But the point is, you have a certain net profit. That means whatever you put in, if you get a little bit more out, so let's say you put this much into it, okay, and you get, we change green, and you get this much out. Well, this is the amount of money that you make, okay? Force is the exact same way, all right? So last time we talked about Newton's laws, you have equal and opposite force. So if I push this way, which way am I going to go? Oops, I forget this stuff. Oh, breaking stuff. So what you're going to see is we can also have uneven forces, all right? So most of you guys, unless you live really close, probably got here by using one uneven force, where you have an engine that drives a drivetrain that pushes the car, okay, and pushes it forward. Okay, depending on what type of car mine takes a while, okay, because I drive a tank. Some people, there are two people trying to race this morning at like 5:30. Why are you racing at 5:30 in the morning? Like, okay, right. Anyway, so net force, okay, is basically the difference between like a push and a pull. Okay, if you think about tug of war, all right, if anybody's ever played tug of war, you have dogs or whatever. Okay, my mom's pit bull thinks he's strong, and he always cheats. So I'll grab the toy, and he yanks it before I get a chance. I'm like, if I get a hold of this, you can't get this from me. And he's pulling, and he's pulling, and he's pulling. Okay, our forces are equal. Okay, this is what we're looking at. So if you have a push one way and a pull the other, you're going to subtract them. Okay, and you can basically figure out what's going on. So this is called a force diagram. Okay, this thing over here on the side. And these arrows are literally the forces. Okay, so if you're doing anything with engineering, okay, if you're doing anything with designing cars, if you're doing anything with anything that's propelled, like propulsion, that sort of thing is, you would use something like this. Okay, and so when you look, the net force is all of the objects going in one direction. Okay, got a chat. So And guys, a couple of people have asked for either a breakout room or assistance with one assignment or another. That's really awesome. If you are remote, we can do a breakout room, and if you're in person, we can talk individually, after we get done with our notes today, okay? So, force diagrams. The line represents the force, and a lot of times, even though, and this is great for me because I can't draw anything, okay? But if you have a car, or you have a bird, or you have a horse, or you have whatever, they normally draw it like a box. So this could be a person, it could be an elephant, it could be whatever. So you guys right now are being acted on by two forces, okay? And hopefully, if they're not equal, you probably are going to fall on the floor or float up, okay? Your forces, y'all look around like, forces? Okay, your two forces that you're basically dealing with is a normal force and the force of gravity. So the force of gravity is forcing you down into your chair, in some of y'all's case onto your desk, and then onto your shoulder and whatever else y'all got going on here. Right? But the force of gravity pushes you down. Earth's gravity, 9.8 meters per second. We talked about the fact that you're way fatter or way skinnier on different planets, which is kind of interesting, okay? But the other force that we went over a little bit is what is called normal force. That's the chair pushing up on your butt, okay? It's pushing on the butt. Your butt is being pushed on as we speak. I don't know how y'all feel about that, but there's some butt action going on. So Sean shook his head. So the point is that you have equal forces. That's why you're not going anywhere. Now, if you were to lean to one way or lean to the other, or push from one side to the next, or to push your chair back, that is going to be an unequal force, which causes movement, okay? So you have four types of forces. There are more, but for our purposes, four types, okay? You have, where can this ball go? Oh, let's use these. Y'all don't know where I have stuff stashed everywhere. So I have they're supposed to be little plastic golf balls, but they're really like ping pong balls. So in my hand, you have the force of gravity, you have normal force. You have the normal force here, okay? Now, if I was to use an applied force is this. Oh, hold on. Kobe, oh, Shaq, oh, got him. Yeah, okay, they're everywhere. I know there's 5 of them. There used to be like 8, and this happens often, so they get lost. But the point is, when I applied a force to them, they went and moved wherever, okay? I was not very accurate because I have to throw harder to be accurate. So, aim right for the bun hole. That's what that's called, is a bun hole. You have to compensate for the bun movement. All right, so anyway, they did not stop. They're all over the place. I see one over there. They didn't stop until they were acted on by gravity and friction. Okay, we talked a little bit about friction in the last unit. So these forces are things that act upon you, okay? And they are allowed, they're everywhere. I see another one over there. They allow you to either move or stay still, okay? So this is something that's very commonly seen, okay? You could be pushing a block, okay? In this case, it's a block, whatever, okay? And so we talked about before spring break, which means y'all completely and utterly forgot it, okay? But the force, the units for force are newtons, N's, okay? So what you're gonna see is if 2 people push a block this way with 18 newtons of force, and 2 people push a block this way with 7 newtons of force, that means basically your net force is 11 newtons going to the right. This is pretty common sense, but it's a way for us to come up with a concrete way of judging, like if I was to throw this cork, and these are unpredictable, so I'm not going to really throw this. It might hit or drop it, hit somebody in the eye or something. But the point is, the amount of force that I have to put into it, you can calculate if you wanted this cork to go 60 miles per hour, exactly how hard you'd have to throw it. Okay, which is kind of cool if you think about baseball or soccer and how hard they kick soccer balls and things like that. The velocity that they're everywhere. I kind of want to get the weight one out, but bad things happen when that comes out. So this is something that is really pretty simple, okay? And it's going to be something that you guys are going to practice. So basically, you're going to subtract the force going this way and the force going this way, okay? Opposites cancel each other out, okay? They cancel each other out. So check this out. Exerting a bigger force on an object causes a change in velocity, okay? So if I was to take one of those ping pong balls, which are, I see like 3, there's one, and throw it really, really, really hard. Okay, now they don't weigh very much, so they wouldn't accelerate super, super, super fast. But if I was to throw something really, really, really hard, it would go at a higher velocity. It's pretty simple, okay? And if you have something bigger, let's say hypothetically, a weighted special physics ball, it weighs 2 pounds, okay? You would have to put much more force into it. I'm not gonna do it while you expect it. I'm gonna wait until you're like not paying attention and then attack. Yeah. No. I threw a die too. Yeah. Yeah. She always gives me hell in the chat. That's why. So now I gotta give her half the time she's over here. All right. So anyway, this 2 pound ball would take much more force to get, say, 12 to 15 feet diagonally away from me than those ping pong balls would, okay? So we already dealt with this, okay? This is the most important formula in physics. FEMA, or FEMA, whatever you want to say. FEMA is not very popular, especially for those people from New Orleans, but force equals mass times acceleration. The bigger the mass, the slower the acceleration, okay? This is very, very, very simple, and it's a review of some of the things that we've dealt with in the past, okay? But it's very important to this. So we don't care about that. Let's look at friction, okay? Anybody see the pandemic thing where they put baby oil in the floor and they were pretending, well, not pretending, but they were actually like running in place in the kitchen for exercise? First of all, I would kill myself. And the one dude fell and he couldn't get up because it was still on the floor and he was like, had to slide. It was worthless. Some people are very stupid. But the point is, if you eliminate friction, if we did not have friction, we would slide out of our chairs. Okay, we wouldn't be able to walk. Okay, we'd be sliding all over the place. Okay, you've seen videos of people on ice and they just absolutely eat it. Okay, and it just depends on, I about fell yesterday on some leaves, full disclosure, because they were slippery. Okay, well, friction, the slipperier two surfaces are, the lower the coefficient of friction. Okay, that's why floors like this, especially in kind of the types of shoes that I'm wearing, that you will hit the ground before you even realize that if there's water in the floor. Okay, because there's not a lot of grip on the bottom of these. So that is friction. Okay, friction is important for us. All right, and we have 2 types. You have static and you have rolling. Okay, rolling friction is basically what it sounds like. Okay, you box. except for play on that phone behind your book bag. Only there was like a clock at the bottom of the screen right there, or on your computer. This fool just said, I'm looking at the time. I haven't heard that one in a while. It's a bad one. All right, so rolling friction is exactly what it sounds like, the resistance for something, you know, turning. All right, so these are the two types, and we've gone over that a little bit. I really want to do this, okay? So, and I do know where the roof access is, and we may do what I did at Rocky River and throw things off the roof. I just got to figure out where we're going to go to do this. I'll probably throw it there, and y'all will be down at the bottom. Yeah, I'm not letting you go on the roof. No, I don't feel like opening myself up to that. But we can do a demonstration and determine how much time it takes for different objects to fall. Now, we saw in the vacuum when we talked about if there's no air resistance, even a feather and a bowling ball will hit at the same time. Well, that's not a vacuum outside. So if you were to take a remote, a piece of plastic, a canteen for water, they'd all hit the ground at a different speed because of air resistance. That's basically how much the air is stopping them from moving through, space. Okay, so size, shape, and speed basically determine air resistance. So if you were to jump from the roof, and I'm not advocating that, we go, whee, you would hit at a different rate, not because gravity is different for you than something else, but because the air is resisting you from falling. Okay? So pretty interesting. Now, what you guys are going to do, and I'm going to spend the next 10 minutes trying to find these ping pong balls that are all over the place. But what you guys are going to do is you're going to go back to your lesson page, and you're going to click on the net force practice. Now, I can send y'all this link as well. Open, darn it. Okay, when you go to the net force practice, historically, I've allowed it to be a, a Google document. It's a pain in the butt to do it that way sometimes. So there's a couple of ways that you can do this. One, you can use Google Draw, okay, to do that and insert drawings, okay, or you can go in and you'll have to make a copy of it because you can't do it on my copy. But you can go in and you can click Insert, you can click Line, and you can click Scribble. Okay, and if you click Scribble, you can do exactly what it sounds like. You can scribble. Okay, so what it's going to allow you to do, hopefully I can get rid of that. There we go. What it's going to allow you to do is to go through and do these net force type of things. Now, this one is just asking you to go through and basically identify the forces. Now, these you'd have to draw your own. So that would be where you need to scribble. Or if you wanted to just insert a line, you could insert a line as well. Okay? But just as an example, if you go to this one, go View, Present, and then you go here. Okay? Let's say number one. Number one asks you, what force is this and what direction? Because remember, force goes in a specific direction. So what you're going to do is count the boxes. The longer the line, the more the force. Okay? So number two has way more force than number one because it's a longer line. Okay? So what you're going to do is you're going to say 1, 2, 3, 4. So it's 4 newtons. Okay? And you're going to the right. It's pretty easy. The main thing that I want you to be able to do is to see, hey, 4 newtons to the right, whatever the situation may be, okay? What I want you to be able to do is be able to read these diagrams, okay? Now, I'll be coming around, okay, and helping people if necessary, while also finding all of the random things and probably unleashing more random things. There's a tennis ball over there. Jesus Christ. All right, but you guys have the opportunity to go through and do this. Now, when you go through, this gives you the diagram where you have to draw your own, okay? Then here, you're gonna go through and tell me, okay, what basically is going through, what basically is happening, okay, in this. So if you look at number 2, where's number 2? Here it is. Okay, you have 1, 2, 3, 4, 5, 6, 7 newtons to the right. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 newtons to the right. So that 7 plus 13 would be 20 newtons to the right. Okay? So the key here is if they go in opposite directions, they have to cancel out. Okay, so this is a little bit different and it gives you a hint with the other thing. Now, realistically, you could probably get this done today. Okay, so you wouldn't have anything new, and that comes along with kind of what we're talking about with the, hey, make sure that you get stuff done in a decent amount of time. Okay, so that's what you guys are going to be working on. I am going to be assisting those who need it either in the chat or in person. And then we will come back together probably at around 1:35-ish. So in about 30 minutes to go through and close out the day for today. All right, let's get it.